All right, so here we go. The last equation that we did was an endothermic reaction. I want to show you an exothermic reaction just so you can compare the two. So the first thing that you need to realize is you need to take a look at your numbers. And the first thing you always want to determine is whether it is exo or endo, right? So if I take a look here, I have E forward is minus 10. In your brain, I'm hoping that you're screaming that this is exothermic. All right, so now knowing that piece of information, I'm going to start making my drawing. Okay, so I'm going to make just a regular drawing, just like we've been doing. My lines are a little wonky, sorry about that. Okay, now we know that it is exothermic, right? So if you remember from exothermic, you have two choices. You need to decide whether your reactants are a higher energy than your products or your products are a higher energy than your reactants. When we talk about exothermic reactions, remember the whole reaction releases energy. So that means that my reactants are at a higher level than my products. So I'm going to put my reactants here. We go up to the activated complex. We go down, and now we are at the products. Okay, so that is what your initial graph should look like for an exothermic reaction every day, all day. All right, so now what I'm going to do, I'm going to draw some lines just to orient myself. Okay, so I'm going to draw a line here. Remember, this is exo, so that means that my products are going to be on the lower energy side. So I'm going to put products down here. And then I am going to draw myself another dotted line across. I'll try and keep it as straight as possible. Okay, this one is going to be my reactants, and I will put it right near my reactants, just so you can see what's going on. The next line that I need to draw is going to be the highest point in the graph. Whoa, I missed it a little bit. That's okay. I'm glad my iPad erases. So let's fix that. We are going to go up here to this line and down here. Okay. This is going to be the highest point, which is considered your activated complex. So I'm just going to put AC. Okay, so now let us label things that we know we need to label. So the first thing is going to be delta E. Delta E is always the difference between the products and the reactants. So I'm going to label it. This is delta E. The next thing I need to label is going to be EA. So EA is always going to be my activated complex to my reactant. So I'm going to draw it. Activated complex to my reactants. That is going to be EA. The other one that I know is EA prime is going to be my activated complex to my products. That is EA prime. Okay, so now that I know all of that information, let's take a look at what the problem is asking us for so I can label all the stuff I need to label. So the first one is, it says to always place your reactants at energy level 0. My reactants are here, so guess what? That's 0. Okay, that's the easy point. And then it says that EA prime is 40 kilojoules per mole. Okay. Let's start with the delta E though. So delta E and A says that our delta E forward is going to be minus 10 kilojoules per mole. So that means that from here to here is minus 10. So your number that goes down on the products is going to be minus 10. Okay, hopefully you guys saw that. Now, when we talk about EA prime in the problem says that it is 40 kilojoules per mole. That means from our activated complex all the way down to our products. is 40, right? Well, I already have 10 here. So that means this part is going to be 30. So the number that I'm going to put up there is going to be 30. Okay, hopefully you guys were able to see that. Now I am going to erase some of the extra stuff so you guys can see the final graph the way that it should look. Okay, so I have my 0 here. This is 30. Okay, and that is the answer to problem number 5. Hopefully that was helpful. All the other problems are going to be variations on that particular theme. All right, y'all.